Alright, so today we're looking at exponential functions, their transformations, as well as the domain and the range of exponential functions. So, if you recall from your algebra background, the function transformations, let's say you have y1 equal to f of x, and that can be just any function as it goes along here, and we'll call that f of x. If you have y2 equal to f of x plus or minus k, what that's going to do to the graph is shift it up or down by k. If you've got plus k, it'll shift it up, and minus k will shift it down. Also, remember that if you have f of x plus or minus h, so notice if we have something inside those parentheses, then that gives any given point and shifts it left or right. One of the things that's kind of interesting is that if you have a minus h here in the parentheses, that actually it's going to shift the function to the right. And if you have a plus h, it's going to shift it to the left. And the question is, why? Why does that happen? So plus h shifts left, minus h shifts right. Why does that happen? And we're going to look at that in the answer to that question in the context of exponential functions. So let's consider just a good old y equals 2x, and we'll plug in 2x plus 1. So notice here that this is your f of x, and over here this is your f of x plus 1, where we've just replaced everything with x here with x plus 1. So it's not on the outside over here, it's not down here on the same level as the 2, it's actually up there where the x is. So that's going to, based on what we said earlier, what we've seen with functions previously, it should result in a left or right shift. Let's go through a quick table and see what happens. So plug in some values here for x. 0, 1, 2, 3. So when x is 0, 2 to the 0 is 1. When x is 1, 2 to the first is 2. When x is 2, 2 to the 2 power 2 squared is 4. When x is 3, then we have 2 to the third, which is 8. When we have this function over here, y equals 2 to the x plus 1, when x equals 0, the y value over here, the function value, is 2 to the 0 plus 1. So that's 2 to the first, which is 2. So you can see already, for this x value, I'm getting the x value that was associated here with a later row. It's almost like it came earlier here. Oh, okay. So when x is 1, then we have 2 to the 1 plus 1, which is 2 squared, so 4. Once again, we're here with the x value of 1, but we're getting the y value that corresponded to, over here in this function, the row that was a little bit later on. So it's almost like it's pushing everything sooner here. When x is 2, we have 2 to the 2 plus 1, which is 2 cubed, which is 8. When x is 3, we get 2 to the 3 plus 1, which is 4, so 16. And if we graph these on my very poorly not to scale xy axis here, this first function over here, we'll use the black ink. So when x is 0, we have a y value of 1. When x is 1, we have a y value of 2. And when x is 2, we have a y value of 4. When x is 3, all the way up here, we have a y value of 8. Okay, that really should be shifted a little bit over and up there. But anyway, you get the idea. Exponential graph. Y equals to the x. Now in red, we're going to graph these points. So when x is 0, we have 2. All right, wait a second, something's wrong here. We'll fix that here in a minute. That dot should be down here. When x is 1, we're plotting at 4. Okay, that looks right. And when x is 2, we're at 8, which is way up here. And I think I need to fix this graph here. Let's go ahead. Oh, that one's fine. This is the one that needs to be fixed. So when x is 1, we should be plotting 4 right there. And when x is 0, we should be plotting 2. So there we go. So we've got that point. What I didn't show is that this previous dot here, the 1 with the 2. So we can see it's almost like those later values all got shifted to the left. Okay, so that corresponds to later, farther rows down here are appearing as earlier rows over here. So we have an x plus 1 situation, and even though it's a plus 1, you might think, oh, that's going to shift my function to the right. In fact, it shifts it to the left, because what happens is those y values get hit sooner. Oh, there's that happy little 1, 2. dot there. Thus, 2 to the x plus 1 is a shift left by 1 because the function hits those y values sooner, so to speak. Alright, let's go ahead and model this on Desmos real quick just so you can know that I'm not pulling a fast one here. So here we go. You can see the function that's in black is 2 to the x and 2 to the x plus 1 blue, and we can see clearly it looks like it's shifted over to the left there. Alright, let's go ahead and change that to the x plus 2, and you can see it's now shifting everything over. We're going to keep that as is, we'll still have a different color, x plus 2 to the x plus 2 and 2 to the x plus 10. So whoops, well I already moved it to the right. Anyway, so you can see the green one there, x plus 2, everything from the black line is shifted to the left. Y equals to the x plus 10, shifted all the way over here to the blue, so clearly shifted to the left. If we replace those pluses with a minus, then boom, now everything's shifted to the right. The black line right here is our baseline, so to speak, and then minus 1 over here to the blue, minus 2 over here to the green, and minus 10 all the way here to the purple. If you didn't believe it before, that should be enough to convince you. And then just to verify, we stick that plus 5 or plus 10, it's going to shift the whole all the y values are shifted up. If we have a minus, all those y values are getting shifted down, which is just what we would expect. Alright, now that's transformations. Now we're going to look at domain and range. If you recall, the domain of the possible x values is the range of the possible y values. So let's go ahead and look at our 4 types of exponential graphs. We have positive growth, positive decay, and negative decay. And we're just very quickly going to look at and examine the domain and range on each of these 4 types. So here we go. On this, the domain, that's all the x values. Every possible guy can be an x value there. The range, if you remember, we never actually hit the x-axis here. It comes closer and closer and closer, but never actually hits. So we never get a y value equal to 0. It gets really close to 0, but never actually hits it. There's an asymptote there. So not 0. So we're looking at all the y values greater than 0 for an exponential growth. That's positive growth. Negative growth, once again, domain all reals. The range, same thing, only we're all negative, so all y values less than 0 for that. Moving on down here to the decay functions. The domain, once again, all reals. Yeah, any x value can play this game. And the range, well, it's all y values greater than 0. We can see we don't actually hit the x-axis here, so we have all the positive y values. Decay, just like you were expecting, domain is all reals. Range, all y's less than 0. Alright, that's the domain and range for the 4 types of exponential functions that you can have. And at the very beginning we talked about the transformations. Thanks for watching.